Hi, I'm taking Paul McWhorter's Raspberry Pi lessons, and we started figuring out how to use the GPIO pins this week on lesson 4. And I've already submitted a homework video for that, quite a long one, using uh, PySimple GUI as well as doing it in the terminal. So you can check out that video if you like as well. But this one is, I thought about it and I said, well, blinking one lead's cool, but blinking multiple leads independently would, I wonder how I would do that in Python. Well aware how to do it in on Arduino, and I thought I probably want to do it a little differently here, because with Python we have the ability to do threading, where you have multiple processes going on at one time. So I said, let's give that a try and see how it works out. As you can see over here, I got 4 LEDs wired up with resistors for each. They're going pin 6, pin 13, pin 19, and pin 26. There is where the resistors are going to. So I'm going to do it that way. So let's get over to the code. Again, we're on our VNC into the Raspberry Pi just to get the screen on coming up on my PC, but all the code is running on the Pi, so not a problem there. So I decided, like I said, we were going to do 4 of them, so we had to import the threading and did a little reading on the threading and everything, so got that figured out. So like I say, we're doing 4 of them, so we had to do this 4 times as output, declaring them as outputs. And then I knew I was going to I wanted to, these are not going to be a number of blinks, but just continuously blinking. But I did want to have varied on and off times for them. If they were all the same, you could have done it without doing the threading, but if you want independent on and off times, I did that. So we have red on, red off, yellow on, yellow off, so on down here for the green and the blue as well. So, and they were going to have to be global variables, so we could address them in each thread. So we got that going on. I guess they really wouldn't have had to been global, but I just we could have put them just down there, but I had something else in mind, so I've just put them up there and made them global as well. That way you knew where to change them if you wanted to. So then for each thread, a thread you call by calling a function, and each of these functions, so I got R blink, Y blink, G blink, and B blink, and they're all copy and pasted of each other, except they got different variable names on them. So I got R on, like I say, the R off, and so, and they each have their own output number and everything. So we're repeating our code and just changing up the different variables that we're using, global variables. And basically did that 4 times in a row, and then we call our threading.thread, and we have a target is the R blink, which is the function we're calling. You do it without, we're not putting any arguments up there, so we don't, and when you do this a target, you don't do the arguments in that way anyhow. But we did want to kill them when we kill the regular program, stop the regular program, so he made our daemon true. And this is just a shortcut. Instead of naming the threads, you just telling them to start individual threads, because we're just starting up 4 threads. And then basically we're coming down here, we're just letting those threads run on their own independently, and we're letting them run as long as we want the program to run. But then we just quitting out of it when we type anything in our for our input. It's going to give us an input down here, and that way when we stop, we can, last thing we do is do our GPIO cleanups. So we can see how they're running. Like I said, I gave the on times and off times. And go back up here, like 1 second on, half second off, 1.5 on, 1.5 off, quarter second, and then a third of 0.3 seconds on and off. So green one you'll see is blinking faster, and the blue one I got a 5 second on and a 1 second off. So it's going to be blinking really slow. So let's go ahead and run it and see it work. You can see they're all doing their own thing. The blue's going real slow, on for a long time, then off for a second. Green one's blinking on and off really fast. And the red and the yellow are doing their own things. So that was basically what I wanted to show you on that. But then I got to thinking, let me go ahead and turn this off. So we gotta go down here. All right, so 0 to quit. So they're done. So got that all done. I think, man, okay, but I don't know if any of you know my coding philosophy is I hate to do things over and over again when the computer is really typing over and over again, when the computer is really good at doing this stuff. So took 62 lines of code, and I said, we got to be able to do this a lot better. So let's show how we did it using a list for our data. So instead of having all those things that we had to worry about, and then as far also, so we had an on time and an off time, and then you could also, so there's a list of lists. You got lists for each one. So we could also put our pin numbers in here as well, so that we could loop through the pin numbers. So we'll show you how that worked out. So like I said, we set our mode. Of course, we're using BCM because that's what this cobbler thing wants. But then we just loop through with a for loop in here, and it's the B info, and we wanted we loop through the I, so that's the outer loop. So we're going that, but we wanted the 0 element in each one of these. So it was the 6, and then a loop 13, 19, and 26, which is our pin numbers that we wanted. So we set them all up as outputs. And then because you can each time you call a threading.thread, it's going to start a new thread, and you don't have to give it a name or anything like that. It's just going to start it with whatever things you send up to it. So we actually only needed one, but we're going to loop through again and bring our index up, outer index up there to it. And this way we only actually, because the info is a whole, all our info, that's all we need to put in here. And we'll have access to all of them, no matter which one we're doing. But, and it's basically the same thing. We're just bringing up our two-dimensional list and putting that info in here. Like I say, our 0 element, we're doing all nums, which is we're bringing in, and our 0 element in both of these places is our pin number, which we needed. And then we also our number 1 element is our on time, and then our number 2 element is our off time for sleeping. And that's all we did. And then down here we just looped through, did pretty much the same way. We're looping through it, and this time we did need an argument in it. And the way you pass an argument to a thread, instead of doing it like you normally would pass it, just put in parentheses here, you have a separate thing that we do, and it's called args. And if you're only passing one, you still need a comma in there. You have to have that trailing comma. I found out the hard way. Why isn't this working? Yeah, I remembered. Yeah, you need a trailing comma if you only have passing one thing up like that. So, and again, our daemon was true. And then we're starting it. Yeah. All right. So anyhow, and then it's the same thing here. We're just waiting for any input to quit, and then we do it. So instead of the 60 some lines of code we had in the other one, this one we're doing it with 21 lines of code. So that suited me a whole lot better. So well, show it running. The numbers are a little bit different here, but similar. So there we go. And the cool thing is, if we want, I don't know how many we actually could put on here, but for each one of these, the only thing you'd have to do is you'd have to change your, whatever your range is that you're doing, and add a couple more lists to our list of lists up here, and you could have as many as you want and wouldn't take a single extra line of code to do it. You just add to your list of lists up here. And like I say, change our indexes on our range. We could probably blink 10 LEDs if we had it. Anyhow, I didn't do anything with the GUIs this time. I figured this was just showing the process of threading. Thanks for watching.